Hello friends, welcome back to the data structure tutorial, and in the last video we have discussed about what is linked list and why should we go for the linked list. And now today we will be discussing about the very first type of the linked list, that is singly linked list. And singly linked list is just a collection of node in a single direction. So how to create a singly linked list, that is our first task. So let us discuss about the creation of node. As we have discussed in the previous video, node is a collection of different fields. So here I have given the diagrammatic representation. Whenever you create a node, the first block will be for your information. As per your requirement of the data, you can declare the data type for this information, and this second field will be treated as address of next node. So for this example, I have given a name to this first field is info, that is information, and the name for the second field will be given as next, that is address of next node. Then how to create this node? So as we are dealing with the Java, so to create this kind of structure of a node, we need to define one class. This will be an inner class. I'll demonstrate you after the explanation of theoretical part. So we will be creating one class node. So this is our class which having a two data members. One is integer information. So I'm considering this information as a integer information. And second part is a it's a object whose name is next. So we are creating an object of node class itself, so it will be a reference for the next object which is representing your second node. So you have to just remember that whenever you want to create a node, you must have the structure of a node, that is a class node with two different field. One is for integer information and another one is for the node next, and next is an variable name which will be storing the address of the next field. Okay, now we want to assign the information to this and next address, and we have to allocate the memory to this box. This is just a declaration that we have not allocated to memory to this node. Now how to create a node means allocation of the memory. So memory allocation is done through this keyword, and that keyword is no, as we know that. So whenever you create a new node, you have to create an object of this node class. So this is a class node, and of that class node you are creating a new object. I have named it as a temp, that is temporary object, or you can name as per your convenience. So node temp is equals to new node. So what will happen, this new keyword will allocate the memory to this temporary. So how much memory it will allocate? It will allocate the memory is equals to the data members of node. And how many data members are in the node class? There are two data members, one is information and another one is node. So with the help of this new keyword, you will getting a new node whose name will be temporary. It's a reference name which you have given, and this node will get a certain address. Suppose that address is 500. This all things are happening through this line. Node temp is equals to new node. And now you want to store your information into the first block. And let us assume that the variable data is consisting of your data. So inside the temp, inside this temp, there is a field whose name is information. So temp.info is storing the data. So whatever data you will be carrying, for example, in this case, if data is equals to 5, this value data variable is carrying. So in the temps information field, so this is your temp. Inside this temp, you are storing a valued data, that is 5, and you are also storing one value, that temp dot next. And what is the next? Next is a object of node, so it's an address. What address you are pointing? You are pointing to the null, means there is a no connection with the other nodes till now. So the first block is containing your information and second block is null. So throughout this tutorial, whenever I'll be saying that we create a structure, so you have to consider this class, and whenever I'll be talking about creation of a new node, you have to write these three lines. Now the next point is we will be talking about singly linked list. So singly linked list is just a collection of such nodes in a sequence one after another. So how to create that? So there are certain steps. So the steps are creating a singly linked list. First step is create a node. So we know that how to create a node. So for this step you have to follow these things. You need to declare one class and you need to create a new node. We have just discussed how to create a new node. Okay. Then we have to check one condition. If existing list is available, then assign new node to the start. So start will be our pointer. It will be another object. So let's say this node class having another object. So I'll be declaring here, suppose I'll be demonstrating it. So don't worry about it. Suppose we have a class node and there is a new reference variable object start, and which will be pointing to null, means we do not have any list. So you will be checking that if your start is null, if there is a nothing to start, it means that you have only one node that you just created. And suppose that node which you have created is a temporary node, I will be writing here, and the address is 500, the data you put is 5, and the next field you made it as null. And if you don't have a list, so this node itself is the only node available with you. So you can make this node as a start. So what you will do, you will assign this address to the start pointer. So we'll be discussing it later on also. But if that is not the case, means you have a already existing list. So suppose we have a list with certain data, 7, 78, 55. I'm taking the random values, and every block having some addresses, suppose 700, 980 and 650. These are the addresses of each block. So this will be your starting point. So we'll name it as a starting pointer. So starting is pointing to the address 700. Then the next block of the 700 is pointing to 980. So this block, and 78 is pointing to the 650. So that is the next block. And this is the last block which will not pointing to anywhere. So this first node is a new node which we have created through this structure and the creation of new node. Then we have checked that if there is a no start, but there is a start available whose address is 700. So what you will do, you have to insert this new node at the different locations. So there are three possibilities. You can add this temporary at the beginning of the list, or you can add that node at the end of the list after this, and there is a possibility you can add in between somewhere, and then you can make this connection. So we will be writing algorithm for all these three, and then we will be implementing. So there are three conditions for insertion of a node into the list. So let us write the algorithm one by one. So let us write an algorithm for insertion at beginning in single linked list. So the very first task, we must have a structure, and then we will be creating a new node. Now here is the structure of a node which we have discussed previously. So we have a node with two sections, so node, and now we want to create a new node. So we know that how to create a new node. So here we have created a new node with the structure. We have created the object type which will allocate the memory. So let us assume that this is your temporary. So this is your temporary which has certain address. So let's say that the address is 500. So 500 is the address of the newly created node whose name is temporary. In the temporary's information, you are adding some data. Suppose that data is 42, and you are making the next field as a null. So you just created a blank node with the help of the structure and creation of a nodes logic. Okay. Now we have to check whether we have an existing list or not. So if we do not have an existing list, so what it means, you will be having a start is equals to null. So you have to check it that if you will be writing if your start is equals to null. You will be writing start is equals to null. What it means that your starting pointer is not pointing to anywhere, means you do not have anything. You will have only one node and whose name is temporary. So what will happen if you don't have any list? So this node itself become your starting point. So it's a starting point for your list. So you need to assign the address of this temporary, which is 500, to the variable start. So to the variable start, you will be assigning the address of temporary. Now for this instance, what is the address of temporary? It's a 500. And what is the starting address of for the start? It is a null. That's why we are coming to this if statement. So the 500 will be assigned to start. Now start is pointing to the node whose address is 500, and you have only one node, that is 500, with the data 42 in your list. So it means that you have a list with single node only. Now if there is not this case, means your start is not null. If your start is not null, so this start should not be there, and this will be your blank node. So else condition will be there. So it means that you have a existing list. So let us assume that this is your existing link. So this having an address suppose 800, the next block will be having suppose address 700, and this will be having suppose 400. We are taking the random addresses. It has certain data suppose 71, this has a certain data suppose 8, and this have a certain data like 13. So this block is pointing to the next one, so it will be pointing to the address 700. This block is pointing to the address 400, and the last block will pointing to nowhere, so it will be null. And who is your starting point? So this will be your starting points. So what is the current value present in the start? It is a 800. Okay, so why we are doing this? We are not coming to this if part, we are coming to this else part. It means that we have a existing list, our start is not null. It means that start having some value, and that value is 800. Okay, now what is our condition? We want to insert at the beginning. So after insertion of this new node whose name is temporary, that has to be insert somewhere here. Okay, so suppose this is your 42 whose next field is null and address is 500, and whose name which we have given is as temp, because that's a newly created node. And this one is your existing list, so I'll be writing as it is, whose address is 800, the value is 8, these are connected, this is 400, this is 700, 13, and next field is null, and this is having 400 address, and all these three nodes are connected except first one. So after insertion of this newly created node whose name is temporary, how your link should be looks like? After the temporary, you want the address of 800, and where is the 800 stored? In the variable start. So this is your current starting point, right? Okay, so but you want to connect this 42 with the 71, means after 500 800 should be connected, right? So that this next field must have an address of 800, so then only this will be connected, right? So the null has to be overwrite with the 800. So in the temporaries next field, this is the next field, temporaries next field, you will be adding the address of 800, and where is it is stored currently? It is stored in the variable start. So how will you write? You will be writing temp, it's a newly created node. In the temporaries next field, it means that this is the field. You want to store the address of start, so you will be writing start. So what is the current value of start? It's 800, where you have stored temporaries next. So temporaries next is 800. So this is connected now. Okay, so we have successfully added a new node at the beginning of the list. But who is the start now? It should not be the start, right? Start should be this one. This will be your starting point. So the address of temporary, that is 500, has to be assigned to the start. So the next line will be start is equals to temporary. So what you are doing? You are assigning the address of temporary to the start. So automatically this becomes your start, and you are pointing to the next node, that is 800. Now start is not here, and start is at the first node, that is 500. So we have successfully inserted the new node at the beginning. So only you have to remember that always create one structure and create a new node. Check the condition whether the existing list is present or not. This is the logic for existing list present or not. If not, then you will be coming to else part, and you will be drawing the diagram. So temporary should be at the beginning of the list. So in the next field of temporary, you want old start, so that we have done here, and this temporary should be your new starting point. So you are assigning the address of temporary to the start. So this is the algorithm for insertion at beginning. Now to make it simpler for the implementation, simultaneously we will be writing a Java code for this, and we'll construct an entire singly linked list program for all the operations. So let us open VS Code. So I have already created one folder whose name is DS tutorial. Inside this folder, I will be creating one file. I am naming that file as demo SLL, that is singly linked list dot Java. And we'll be creating one class, a normal class, which will be having the file name, that is demo SLL, and we'll be writing your main method. So public static void main, and here you will be writing your string arguments. Okay, and we'll be creating another class. So I'll keep this for the calling purpose. So I'll be writing another class and I'll be name that class as suppose SLL and operations. So SLL operations is the class which we have created for the separate operation functions. Okay, now inside this class we need to create a inner class for the creation of node. So I'll be writing class. We have just written it in the algorithm that we'll be creating one node. It must have a two fields. So I'll be creating info. This will be for the first field and the object of node whose name we have kept as next. So this is for what? It is just a structure of node. So I'll be writing in comment structure of node. Okay, and then after this you have to write the logic for creation of a node. So I'll be writing that in every function, or you can write a function, separate function for that, void create one function, void create new or create node. This is the function I'll be creating, and what you need to do, you need to pass the data to this variable. So int data, it will be receiving some data. And now here you need some reference object. So I have declared start whose value will be initially null. Okay, and in this create node we'll be creating an object of node class. We have seen that. So node temp is equals to new node. So this is the memory allocation for your block of a node. Then inside the temps information field, what you will be doing, you will be adding your data. And in the next field of temporary, sorry, you will be writing temp dot next, you will be adding the new value, that is null. Okay, so this function is creating your new node and this is your structure of a node. Now we'll be creating another function, void. I'll name this function as insert at beginning. So I'll be write only insert at beginning. Okay, and what this function will do, it will also receive one data from the main method, and whenever you come to insert data you need to create a new node. So you will be calling this function create node. So you will be calling create a node with this data which you have received. So it will be creating your node. Okay, and once you created the node you will be checking that whether you have a existing list or not. So how to check it? If start is equals to null. So what is start? Start is one of the reference object which is pointing to the starting address of your list. If it is null, then the new node which you have created whose name is temp, it should be your first node. Okay, so I will be writing start is equals to temp. We have written it into the algorithm. Now the issue is you declared this temp within this method, so it will be not allowed here. So either declare this entire three lines inside the insert function, or simply declare this temporary here along with this start. So you will be writing temp is equals to null. Okay, you can write either this in a separate function or you can just copy these three lines and paste here without any confusion. Okay, so we have a temporary node, else if it is not the starting point, it means that you have a entire list with you and you want to add the new node beginning of that. So we have seen the logic that the existing list having starting point, so that should be present in the temporaries next field. So temporaries next will be old start. This is what we have just explained, that temporaries next will be start. So whatever temporary new node you have created here, that should be containing the next address, and that is 800 which is present in the previous start. Okay, and then start becomes your new temporary. So address of temporary is assigned to the start itself. If you feel that we have a many functions, so you will be confusion with this code. So what you can do, you'll keep it simple. So instead of creating a separate function for this, you can write these three lines without creating this function. Here you can write it, but that will be a repetition of code. Okay, this is how you need to write, then the error will not be there. So better way to create a separate function, but every time you just need to call that function and that will be easy for us. Okay, so the next task will be insertion at the end, and then we'll be discussing in the next video.